So now we move on to the next type, which is, they're not all exactly the same, they're a miscellaneous type, but essentially it comes down to there's a sort of a kind of focus on the number of terms in the series. This one, not as obvious, but you just need to sort of look at it a little bit differently and approach it a little bit differently. So let's have a look at this example. We need to sum this series. You can see that each term, you can see what the pattern is. It can be hard to describe, but let's have a look at what it is. So if we let Sn represent the sum to n terms of this series, so we've got let Sn equal 1 plus so on. And what do we put for our nth term? Well, we can see what's happening here. It'll be 1 plus 2 plus 3 plus and so on until we get to the number n, however many terms there are. Okay, which, if we can recognize, hopefully, that there is actually a series in itself. Okay, it's actually the sum to n terms from r equals 1 of r. Okay, so 1 plus 1 plus 2 plus 1 plus 2 plus 3 and so on. We continue. Now it's this series, isn't it, of r from 1 to n, and we know that that's on our information sheet, and with enough practice you'll know that that can be written as n plus 1. So n times n plus 1 over 2. So that's our nth term there. So what that means is that we can, that's sort of the definition of our rth term. Okay, the rth term is defined by n times n plus 1 over 2, which means that our sum to n terms is sigma from r equals 1 to n of n times n plus 1 over 2. Except I really should make that an r, not an n. Okay, that's an r at the front, because r is our variable here as defined by this r equals 1. Okay, so what we're going to do is just expand that out. So from r equals 1 to n, that's r squared plus r over 2. And we can see this is over 2, so that means we can take out a half out the front, and we'll split this into two series. So it's r equals 1 to n of r squared plus, again, half out the front, and r equals 1 to n of r. So we've got a half times now r squared as our sum to n terms from our information sheet is n times n plus 1 times 2n plus 1 over 6 and for r it's n times n plus 1 over 2, and we can go from there until we finally get our answer, so we'll work through that. So as I've worked through those lines, I've just gotten a common denominator of 12, and so you can see that we've got 3n times n plus 1 for our second. What we'll do then for the next line is you can see this common factor here of n times n plus 1, so we'll take that out the front and work through from there, and we'll just leave it in factorised form. So with these last few lines you can see we've taken the n times n plus 1 out, leaving us with 2n plus 1 here. Oops. And plus 3, combine that together and we get 2n plus 4 in this line, but we can also see that we've got a common factor of 2 there, so we take the 2 out the front on this line, but it can cancel with the 12, leaving us finally with n outside of n plus 1, outside of n plus 2 over 6 as our final answer for the sum to n terms.